All right, so this is our last problem. We're considering special circumstances. And um, considering special circumstances would be a huge help to this problem. And actually, if you didn't have any other solutions other than this, uh, it would take a really long time. But with considering special circumstances, everything comes together perfectly. Okay, so let's start the problem. A school has 9 classes with the same amount of students in each class. The amount of boys in class 1 has one more person than the total amount of girls combined from class 2 and class 3. The total amount of girls from classes 4, 5, and 6 is one more person than the total amount of boys in classes 7, 8, and 9. So in the entire school, what is the ratio of boys to girls? So we know that there are 9 classes. I'm just going to make 9 columns to show that there are 9 classes. And just like in the last problem, I made a table to show the data, so everything kind of made more sense. And I'll write B for boy and girl and G for girls. So we don't know how many students are in each class, but we do know that there is the same amount of students in each class. So I'm just going to come up with something really simple, a number super simple that I can calculate with. And the first number that comes to my mind is 1. So why don't we let every single class in the school's 9 classes have only 1 kid? Alright, so I think that is a good idea. We know that the amount of boys in class 1 has one more person than the total amount of girls combined from classes 2 and 3. So if each class can only have 1 kid, this kid in class 1 must be a boy, so 1 there. There is 0 girls. And we know that this is one more person than the total amount of girls combined from classes 2 and 3. So it means that the total amount of girls from 2 and 3 has to be 0. So making them that each of their students are also boys. Now classes 4, 5, and 6. The total amount of girls from classes 4, 5, and 6 is one more person than the total amount of boys in classes 7, 8, and 9. So there is, out of all of these classes 4, 5, and 6, there's only 1 girl. So there is 1 boy in each of the classes 5 and 6. And this is 1 more than the total amount of boys in classes 7, 8, and 9. So there are no boys in classes 7, 8, and 9, for they are all girls. So what is the final number we come up with? So in the entire school, there is a total of 5 boys and a total of 4 girls. And no matter how many students there actually are in each class, the ratio is always going to be the same. The relationship is always going to be the same. So our final answer is 5 to 4. So again, this part is really important if you've so this is helping you with your logic. First and second, the key to this problem was to really think of how I can think of the classes. So there could be 20 students in each class. There could be 45 students in each class. But the main point here is just to find which number will work most efficiently for you. And one might not make sense in a real class, might not really make sense, but in this problem, the relationship will always be the same. And especially when you see that it's always one more person or one more person less. So the difference is always 1, so you would just have ones and zeros. So that would make everything much less complicated. So thank you for watching Through Inquisitive Kids, and see you next time.